And one fascinating feature of collective behavior is that although the animal try to stick into the group, still they can perform some functionalities. In our case, we want to investigate how they stick together, but still try to move away from the static thread. So we have a bunch of tiny little particles in micron size, and we copy one hemisphere in carbon, so it's black. The other one is rather transparent. So when we shine laser on it in different position in respect to the particle, and you heat up partially, which generate flow in its environment, which is a water-liquid mixture. This is similar to the case that you're paddling a small boat. You do it more on the side, and it goes in the curve. If you do that in balance, and it goes straight. So this is a way we manipulate movements of individual particles. And for the collective movement, we have each individual particles or agents or animals, whatever you like to call it, they want to stay together. So it's a rule of cohesion, and to keep on going and approach the center of the group, you can of course just bump into the center. You can imagine that the center is so crowded, everyone wants to get in. So the best way, I guess, or most intuitive way, is to approach it like from the side. So it's generally you go to the direction that's towards the center but deviated by the angle. And you can either go like to the right or to the left. This gives you like two chances, and we make them, the particles, take the choice by its neighbor. So if more neighbors going from one side, it follows. But still, it's like either this or that, and the angle is fixed. My personal impression is that I can think of some animals, they try to keep the most dense area of the group, like in some part in their view. So this is how they work, and as a result, there is a spontaneous symmetry breaking. So eventually, all particles should start to rotate in certain direction. So when the thread or predator come in, this group for individual particles, they still follow a similar rule, choose from two directions, but the only difference is that it does not follow its neighbors, it only choose from the two by which one leads further to the predator. The particles figure out the direction of escape by the interaction within the group. So on the other side, the group also provide robustness of group reaction when there are particles not able to respond to the thread directly. And we consider this as a clue of collective benefit, which is not commonly shown in other kind of experiments. We have a bunch of particles, each individual moving in their own way, by depending on the surrounding. So this is similar by a group to a group of animals. Each animal have their own soul, have their own will, and think about where to move according to what they see. So this could be reflected directly to an animal group